Okay, rate law and elementary step. For example, for unimolecular reactions, for molecule A, so the rate of reaction is equal to K concentration A. For bimolecular reaction, which is involve two different type of molecule, species A and B, so the rate is equal to constant time to concentration A and B. Okay, for bimolecular reaction with the similar species A, so the rate is equal to K concentration A power 2. So the sum of the elementary step can give the overall balanced chemical reactions. Okay, reaction mechanism enable us to understand and control the chemical reaction. Okay, that is a sequence or step in studying a chemical reaction. Firstly, we need to measure the rate of reactions, and then we formulate the rate law. What is the rate law of the or involved in the elementary step, and postulate a reasonable reaction mechanism. So to propose the mechanism for the reaction, there are several criteria need to be considered. First is the elementary step of the multi-step reactions must add to give a balanced chemical reactions. Means that every or each of the elementary step involved need to consider. And then any intermediate that are formed in the earlier step must be consumed in a later step. Okay, normally the reaction involved is unimolecular and bimolecular reactions. Okay, for example, the reaction between the bromine and formic acid. Okay, the bromine is initially in reddish color. When react with formic acid, the color change from the reddish brown to the fade color by when the concentration of the bromine decrease. So the concentration of the bromine can be determined by using the spectrophotometer that can detect visible light absorbed by the bromine. So you can see here that the absorption versus the waveline, which is the change in concentration of bromine is proportion to the change in absorbance. So the T1, the absorbance is higher, and then the absorbance is decrease when the time increase. Okay, the rate of reaction between the bromine and formic acid is also depends on the concentration of the formic acid. However, when we use excess amount of formic acid, which is we want to ensure that the concentration of formic acid is constant, and then the change in amount of formic acid in the solution will have no effect on the measure rate. It is because the reaction is completely occur between the bromine and the formic acid. So the rate is directly proportional to the concentration of the bromine. So the rate of reaction can be calculated by change in concentration of bromine at time t minus 2 initial concentration. For example, when we consider the rate for the first 50 seconds, which is the change in concentration of bromine is 0.0101 minus to initial concentration 0.0120, and time is equal to 50 seconds. So we get the average rate is about 3.8 times 10 power negative 5 molar per second. So we can calculate also at different time and change in concentration. For example, for 100 seconds, so the change in concentration is 0.0846 minus to the initial concentration. So we can get the rate is about 3.4. So from there we can get the average rate of the reaction between the bromine and formic acid. Okay, from the curve, we can determine the instantaneous rate. For example, we want to measure the rate at 100 seconds, so we can get it from, or we can calculate from the slope of the tangent. So we can use this data to calculate the K constant. So let's say at T50, the concentration is equal to 0.101 molar and the rate of reaction is equal to 3.52 10 power negative 5. So when we double the concentration at T is equal to 250, which is the concentration from 0.005 to 0.01, which is double. So you can see that the rate of the reaction is also double by or increased by 2. So the plot graph, the rate versus the concentration of the bromine, we can see that the straight line, which is shows that the rate is directly proportional to the concentrations. Means that the higher the concentrations, the higher the rate of the reaction between the bromine and the formic acid. Okay, which is K is equal to negative rate over the concentration of the bromine. Okay, how we want to convert from the concentration to pressure. So consider the decomposition of the hydrogen peroxide. So from the ideal gas law, PV is equal to nRT. So the change or the rate law is equal to change in concentration of oxygen per time T. So PV is equal to nRT. So N over V is equal to P over RT. So we can replace this concentration of oxygen with the NV. So we can get the concentration of oxygen is equal to 1 over RT times P. So rate is equal to 1 over RT change in P over change in time T. So the instrument used here is called as a manometer. We can measure the increase of the oxygen pressure with the time, where the error shows the mercury level in the U tube. So we can also measure the instantaneous rate from the plot P, pressure versus time. So the instantaneous rate at any temperature can measure by slope or tangent of the curve. Okay, rate of reaction and stoichiometry. How you want to write a rate of reaction? Let's say you have a reaction between 2 moles of A produce 1 mole of B. So rate is equal to negative 1 over 2. Okay, 1 over 2 of the reactant A, change in concentration of A over change in T, time. Okay, it is equal to change in B for your product over change in time. Okay, let's say you have a equation which is reaction between the A and B to produce C and D, which is small a is stoichiometry of component A, okay, and B is the stoichiometry of component B. So rate is equal to, okay, for the reactant you need to put a sign negative to shows that the concentration decrease at the time. So negative 1 over A is equal to change in A over change in T, and it is equal to the product 1 over C change in C over change in T. Okay, means that before you write a rate of reactions, you need to have a balanced chemical equations. For example, here the reaction between the methane and oxygen to produce a carbon dioxide and water. So you need to ensure that the reactions, chemical reaction is balanced, which is the number of the reactant should be equal to the number of the product. Okay, so the rate is equal to negative change concentration of the methane with the time, and also equal to change in concentration of water. This is your reactant. That's why the sign is negative. Okay, while for the product, so it is also equal to change in concentration of the carbon dioxide, and also equal to half change the reaction concentration of the water with time. Okay, how to determine the value of constant K by graphical determinations. Okay, let's say you have a decomposition of nitrogen pentoxide, which is a first order reaction. So for the first order reaction, you need to plot the graph ln concentration versus time, which is from the straight line you can determine the tangent or the slope. So the slope here, the change in y over change in x, it is equal to the constant K. Okay, at the two different temperature T1 and T2, so you can determine the K1 and K2 at T1 and T2.